Good morning, Mr. Dirk is back at it again. Today we'll be graphing some functions.
You know, I think my beard is looking pretty good. It's been short lately, but man, it's looking good right now. Let's go. So what we have here, we have a table, ordered pairs, and a graph. I want you to know that these all represent the same function. When you have a table, the input, those are the x values, and the output, those are the y values. So 3 is an x, 6 is a y. Right here you have 3 is an x, 6 and a y, and you can represent that on a graph. If you remember, the horizontal axis is the x, and the vertical axis is the y. So this part of the table, 3 input, 6 output, is the same as this pair, 3, 6. And you can put it on the graph. X is 3, y is 6. So you went 3 to the right, 6 up. Same for the rest of the pairs. 1, 4, 1, 4. Well, I go 1 to the right and 4 up. And the last one, 5, 8, 5, 8. I can go 5 to the right and 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Voila. There you go. So what I really want you to understand is that the table, ordered pairs, and graphs, these are all representing the same exact function. So now we want to graph the function y equals 1/4 x with the domain 0, 4, 8, 12. So what I would do for this is make a table, my old x, y table. I'm going to put in 4 numbers, so I need 4 spots for numbers. 1, 2, 3, 4. There we go. And domain, those are the x values, so I'm going to plug those in for the x. 0, 4, 8, and 12. To find the output or the y values, you write the equation down, 1/4 x, and you plug in numbers. So I'll start with 0. So we have y equals 1/4 times 0. Anything times 0 is just 0, so that will be a 0. So the point is 0, 0 on the graph. X is 0 and y is 0, so that point is right there. That's the origin. So now I want to plug in 4. So y equals 1/4 times 4. When you do this to simplify, you do 1 times 4 is 4. And then this 4 is the denominator that goes on the bottom. So it's really dividing 4 by 4, which equals 1. So there you go. X is 4, y is 1. You go 4 to the right, 1 up. Alright, now let's plug in an 8. So y equals 1/4 times 8. Again, that's going to be the same as 8 divided by 4, and that will equal 2. So 8 and 2. Here we go 8 to the right and 2 up. Oh, voila. And now we're moving on. We're going to plug in the 12. Y equals 1/4 times 12. And that's the same as 12 divided by 4, which is 3. So 12, 3. That means 12 to the right, 3 up. Bam. Voila. Did it. Moving on. But before I move on, I just want you to know, right? You got the rule right here. You have a table right there. And now you have a graphical representation, right? These are all representing the same function. They're all the same thing. Now we're really moving on. Let's go again. Right now, Super Bowl Sunday, I'm making this video. Who's going to win? We'll find out tomorrow. I want the Patriots to win. Go Pats! Woo! Big game today. We'll see who won. Alright, let's do some more math. So it says, the table below shows the average score M on the mathematics section of the MCAS exam for Tech Boston Academy from 2006 to 2011 as a function of time T in years since 2006. Graph the function. So if you don't know the MCAS, you need to pass this to graduate high school in Massachusetts. You take it when you're a sophomore, so you'll be taking it next year. We're going to graph some data. So this is from year 2006 to 2011. It started with 0. So that the first year is really 2006, and then it goes to 07, 08, 09, 10, 11, right? So those are the years, and these are the scores. So the first thing we need to figure out, which of these is the input, which is the output, what's the X, what's the Y, what's the independent variable, what's the dependent variable. Well, the independent, right, years are going to happen first, and then you get the score. So the independent variable is the years, or x, and the dependent variable, or output, or y, is the score. Alright, so it looks like the x values, these will fit nicely. We got 0, 1, 2, 3, 4, 5. There you go. We don't need any more. But now, this is going to go, the y's is going to go up to 82. Right, so if I count by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? There's not enough to go all the way up to 82. So what I have to do is make a break. I've done this before in class. It's like a squiggly line, right? This is called a break. The reason I can't just start at 68 is because every line is a common amount that is going up by. It's a common interval. That's how you can tell a graph is accurate. You can't just start wherever you want. If you do, you need to make a break and then continue by the same amount each line. So how many lines do I actually need? Well, the highest score is 82. The lowest score is 68. If I subtract those two bad boys, I got 14. So I had 14 lines. So I can go by one. So my lowest score was 68. This is 68. This is 69. 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82. There we go. Alright, so now let's put the points on. 0, 68. 0, 68, that's right there. 1, 73, 1, 73, that's right there. 274, 274, 377, 377, 478, 4, we're 78 right there, and 582. There's 5 all the way up to 82. Alright, and this is not a perfectly straight line. That's what happens when you use real data. It's not going to be a perfect straight line every time, but here you go. We took a word problem, filled out a table, and we put it in a graph. Beautiful job. Moving on. So here we go. We've got this question. It says, make a rule for the function represented by the graph. Identify the domain and range of the function. So we need to make a rule. First, I like to start off with a XY table. How many points we have? 1, 2, 3, 4, 5 points. Alright, so 1, 2, 3, 4, 5. There we go. So I'll fill this out first. The first point, the x is 1 and the y is 1. So x is 1, y is 1. This point, x is 2, and I have to go up 3. So 2, 3. The next point, 3, 5. So x was 3, y is 5. X is 3, y is 5. Now we got 4, 7. So x was 4, y was 7. The last one, x is 5. I go all the way up to 9. So 5 and 9. So when we used to do rules, the easiest way you look at it and say, okay, how do I get from 1 to 1? Well, you try adding first or subtracting. 1 plus 0 is 1. Okay. Will that work for all the other ones? 2 plus 0, well, that's not 3, so that won't work. Then you try multiplying. 1 times 1, well, that is 1. 2 times 1, that's not 3 either, so that doesn't work. So if simple things like that don't work, it's normally a combination of numbers like that. So the first thing you can do to figure this out, look at the x values. If they're increasing by the same amount every time, these are all increasing by 1. It goes 1, 2, 3, 4, 5, right? They're all going up by 1. Oh, that's a plus 1. These are all going up by 1. I'll write plus 1 right there for you. Okay? Now, what are these changing by down here? The y's. 1 to 3, that's going up by 2. 3 to 5 is going up by 2. 5 to 7 is going up by 2, and 7 to 9 is going up by 2. And they're all adding 2, right? Adding 2. So the key to figuring out the rules, you look at the changes in the y, all right? You're looking at these changes. If they're all being added by 2, well, repeated addition is multiplication. Do you know that? Multiplication. Look at that beautiful handwriting. So this is a really key concept. If you keep adding the same number every time, that's multiplication. So I know part of my rule is going to be a 2x because this is being multiplied by 2. There's got to be a multiplied by 2 somewhere in this rule. So now let's check it out. How can it work? If I do 1 times 2, that equals 2. How do I get from 2 to 1? I do a minus 1, right? So will that work for all the other ones? Let's see here. 2 times 2 is 4. 4 minus 1 is 3. Okay, that one worked. 3 times 2 is 6. 6 minus 1 is 5. Good. 4 times 2 is 8. 8 minus 1 is 7. Good. 5 times 2 is 10. 10 minus 1 is 9. Good. So there you go. You got the rule right there. So these complicated rules, if the x's are increasing by the same amount every time, you can check out the y's and then find the rule from there. Alright, so there we go. Nice job. That was a tough one, but we did it. Good work. It is Super Bowl Sunday, but did you know there is a kiddie bowl? Alright, some people watch this instead of the football game. How about that? This is a real thing, apparently. Alright, enough of that. Alright, so now you should pause this video, try it on your own. Pause it. Just do it. Pause it. And try it. Pause it. Okay, here we go. So graph y equals 3x to minus 2 with the domain 0, 1, 2, 3, 4. Alright, so I'm going to make a table for this because I love tables. And they make it so much easier. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Alright, so to find out the y values, you plug the x values, the domain, into the function. So the first would be y equals 3 times 0 minus 2. 3 times 0 is 0. 0 minus 2, well, that's a negative 2. Alright, so negative 2. The next one would be 3 times 1 minus 2, which is 3 times 1 is 3. 3 minus 2 is a 1. Alright, the next one, y equals 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2, that is 4. Alright, if you look, it looks like these are going up by 3. I think that's from this 3 right here. Let's just double check. Y equals 3 times 3, I'm using that 3, minus 2. 3 times 3 is 9. 9 minus 2 is 7. So 7 right there. Last one, y equals 3 times 4 minus 2. 3 times 4 is 12. 12 minus 2 is 10. So it looks like, yeah, these are going up by 3. So we plot these points. 0, negative 2. Well, x is 0, y negative 2. That's down there, so I won't even put that one on. Then we have 1, 1. 1, 1. Alright, 2, 4. X is 2, y is 4. Alright. 3, 7. X is 3, y is 7. And then we got x is 4, y is 10. X is 4, y is 10. But bam. And if you really want to put the last point on 0, negative 2, that should be like down there. Alright. So there we go. We took the domain, put it in the table, solve for the y, solve for the range, put it on the graph. Beautiful. Now let's check out this graph over here. We're going to write a rule. We'll make the table first. Ooh, that's an ugly line. X, Y, much better line. How many points do we have? 1, 2, 3, 4, 5. We have 6 points. Let me get some space. 2, 3, 4, 5, 6. All right. And it looks like we started x at 0 and y is 2. The next point is 1 is x and y is 2.5. And then we've got 2 and 3. Then we got 3 and, what was that, 5.5? Is that right? Hang on. 3 and 3.5, my bad. The 3 is 3.5. 4, 4. 4. And then 5, 4.5. 5, 4.5. All right, so let's see. 0 plus 2. We're going to try the easy ones first. 0 plus 2 is 2. 1 plus 2 is 3. All right, so I'm not adding. 0 multiplied, you can't multiply anything by 0 to get 2. So it looks like we need to do 2 different things, all right? So first we check the x's. Well, those are all going up by 1, right? These are all going up by 1. So that means we can look at the bottom, the y's, and see what they're increasing by. Well, 2 to 2.5, that means it's going up by 0.5 or 0.5. 2.5 to 3, again, that's a plus 0.5. 3 to 3.5, well, we did it again, going up by a 0.5. 3.5 to 4, yep, same thing, all right, plus 0.5. And 4 to 4.5, yes, plus 0.5. So we're going to start off this equation, our rule, with a y equals, well, remember, this is getting added by 0.5 every time. Repeated addition, that's multiplication, so we can write 0.5x. Alright? If you like putting 0 in front, that's cool too. Same thing. So 0.5x. Let's see if this works. So 0 times 0.5 is just 0. And then I need to add 2 to get to the 2. Alright, so plus 2. Does it work for the other numbers? So we'll plug in 1 here. 1 times 0.5 is 0.5 plus 2, 2.5. So that's good. 2 times 0.5 is 1. 1 plus 2 is 3. So that's good. 3 times 0.5 is 1.5. Plus 2 is 3.5. So that's good. 4 times 0.5 is 2. 2 plus 2 is 4. Good again. 5 times 0.5 is 2.5. Plus 2, 4.5. So this works. We are good. Nice job. That was a tough one. If you got it, good for you. If not, right, practice again. We got this whole packet to do. I wish you the best of luck, and I hope you work your hardest. I'm going to say what I normally say. Dirk is out, and I'm going to leave you with some more football and cats in honor of the Super Bowl. Dirk is out.
There's a cat on the field, Jim.
They say it's Halloween season. Incomplete. Hold on. That's what I want to see.
So look at this, Jim. This is like how you ran in high school. Look at that. Perfect form, extension. I mean, and doesn't even get phased if there's people around. Just look. Ooh, look at the change of direction. Does he get both feet in right here at the end, Jim?
Well, he turns it upfield.
That's way too much fun at this point.